So we're going to continue to solve triangles today, but given different information than we were with the law of sines. So let's take a look at this example here. We've got triangle XYZ. I know angle X is 62 degrees. I know that side Y is 2 and side Z is 5. And just to get a visual on what this might look like, I'm going to sketch out a triangle, put X in the bottom left, Y up top. And I don't know how big Y and Z are, so I just have a random triangle here. I don't know if it's obtuse, acute, but it doesn't really matter as long as I label it correctly. So I've got a 62 degree angle down here in this bottom left corner. I've got side Y is 2, so I need to come across the triangle from Y to put that 2. And then side Z is 5, so across from Z is going to go. So last time when we had the law of sines, we looked at using an angle and a side pair of the same letter, but I don't have any of those here. I have a 62 degree angle but no side, I have a 2 side but no angle, and a 5 side and no angle. So I can't create those ratios like I was last time with the law of sines. So we have to rely on a different formula today to help us out. That's what we call the law of cosines. In the law of cosines, it states that a squared plus b squared minus 2ab cosine of c is equal to c squared. So looking at our triangle, we have to figure out what's a, what's b, and what's c, because we have an x, y, and z. We don't have a, b, and c. So when I'm looking at this, if I had a triangle ABC, just off to the side here, if I have an angle C, that would mean A and B are over here, side A and side B is there. So we have an angle, and we know the two sides that are forming it. Angle C is an angle with the two sides of A and B forming it. So when I look at this formula, if I'm using an angle C, the sides A and B are the two sides that are forming that angle. So with the information we have, we can fill in this entire left side of the equation to solve for side C. And it doesn't matter whether the 2 or the 5 is A or B, because if I square A and I square B and then add them together, regardless of the order, I'm going to get the exact same thing. So I'm going to use A is 2 and B is 5 here. I'm going to do 2 squared plus 5 squared minus 2 times that same 2 and 5 that we used for the two side lengths, times the cosine of the angle between them, which is 62 degrees, and then is equal to c squared. So if I go ahead and calculate some of this, if I combine this whole left side, that's going to combine down to 19.6 is equal to c squared. And you can put that entire thing in the calculator at once. Just make sure you're in degree mode because we have a degree angle. And then to get rid of the squared, I'm going to square root both sides. So when I take the square root of the left and right side there, I end up getting 4.4 is equal to c. That tells me this side here, which really, instead of being at c, we should replace this with an x, because that's what we were trying to find, was side x. So I'm going to replace. That way I know for sure that this side that I just found is our x side, 4.4. So that gives us one of the sides. Now, we need to figure out 2 more pieces of information. We have all 3 sides, but we still need 2 more angles. And I could use the law of sines at this point, but I want to show you how to use the law of cosines to help solve for some of this as well, because there's going to be times where the law of sines isn't going to help us out. The law of sines can never solve for an obtuse angle because of the restrictions placed on the inverse sign. So I'm going to look at this and say, well, let's solve for z. I know z is going to be my largest angle because it's across from my largest side. And if I want to solve for z, kind of like we were using c over here, I want to use the 2 sides, the 2 and the 4.4, that form angle z to fill in my a's and b's. So in my initial setup, I'm going to say 2 squared plus 4.4 squared minus 2 times these same 2 values of 2 and 4.4 times the cosine of z is equal to the side opposite being squared, so 5 squared. And now I need to do some calculations. So if I take these, the 2 squared plus 4.4 squared, I'm going to combine these here, and that gives me 23.36 minus, if I take the two 2's and multiply it by the 4.4, I'm going to get 17.6 times the cosine of z is equal to the 5 squared, which is 25. Now, you may be wondering, why can't we just type everything in like we did over here all at once? Well, if we look at what we had, we didn't know the angle this time. And these three values, the 2, 2, and 4.4, are coefficients of that cosine, where the 2 squared and the 4.4 squared are not. So I'm going to do these separately and figure out what these first two are combined, what these next three are combined, and the 5 squared by itself. And now it's an equation that we can solve, like we did back in chapter 5. Now, in order to solve for z here, I'm going to start by subtracting off the 23.36 from both sides. So that will go to 0 over here. Negative 17.6 times the cosine of z is equal to what's left over, 1.64. To get rid of this coefficient, I'm going to divide it off. So the cosine of z is equal to 1.64 divided by negative 17.6. And I'm not going to actually find the decimal fraction. And then to finally get the angle here, we need to get rid of the cosine. And the way we're going to do that is use the inverse cosine. So z is equal to the inverse cosine of this fraction of 1.64 divided by the negative 17.6. And then I can type that into my calculator. So if I use inverse cosine of 1.64 divided by negative 17.6, I end up getting a 95.3 degree angle for angle z. So this one up here is going to be 95.3 degrees. And then the last one, I don't need to use any law of sines or law of cosines. We have two angles here. So angle y, to finish this off, I can say angle y equals 180 minus the 95.3 that we just found, minus the original angle we had, which was degrees. And if I subtract the two of those off of 180, I can end up getting z equals 22.7 degrees. That top angle is 22.7. So when we don't have that angle inside pair like we did with the law of sines, we've got to utilize other trigonometry equations that we can use, and one of them being the law of cosines like we talked about here. And when we're using that equation, whatever angle we're using here, whether we know it or don't know it, this a and b value are the two sides that form that angle. And if we can figure that out and plug in the values, at that point it's just using our algebra skills to solve. But that's the key point in setting it up, is if I know angle C or want to know angle C, the two sides I'm going to use for A and B are those two sides that form that angle.